So for my final example, let me now showcase the perspective or a projective transformation of an image. Again, the usual things. Here, just to be different, we're going to play around with a different image, the Berlin Wall image. We can actually compute the height and width and all of that kind of stuff here from the image itself. And again, it should be no surprise to you so far that now we need 4 points. So for example, in the first image, I'm going to find 4 different points. So I'm basically given them those coordinates here. And for the second image, I found 4 other points. And we need those for perspective transformation. Using these 2 points, points 1 and point 2 in this code, I'm going to compute the matrix, transformation matrix that actually uses these 4 points to compute the perspective transformation. We're going to print it out. And then, of course, as we have done before, we're going to just apply this transformation here. Let me just run this code. Here you see the perspective transform. Again, this should be no surprise. This value is still 1. But of course, we have other values in the rest of the matrix. So this is the original Berlin Wall image, and you'll see why actually this image was chosen to showcase this effect of perspective warp. This is the perspectively corrected image. Now, just being able to apply the perspective warp, and again, the points were correctly chosen, you notice now all of a sudden you get a warp of actually seeing this image right in front, as opposed to in the previous case where you saw an effect of foreshortening. Again, notice here, straight lines remain straight, which was what we had talked about as one of the values of these types of transformations.